टू गणेश अकेडमी। हम सॉल्व कर रहे थे इंजीनियरिंग मैकेनिक्स की क्वेश्चन बैंक। सो कुछ क्वेश्चन हमने सॉल्व किए, कुछ क्वेश्चन बाकी है। चलो लेट्स स्टार्ट विद दिस सेंट्रॉइड न्यूमेरिकल। लोकेट द सेंट्रॉइड ऑफ गिवन शेप। तो ये शेडेड पोर्शन वाला जो है डायग्राम, उसका सेंट्रॉइड फाइंड करना है। सो फर्स्ट आइडेंटिफाई करो यहाँ पे क्या कॉम्बिनेशन है एग्जैक्टली। तो ये जो कॉम्पोजिट फिगर है वो ऑब्वियसली कॉम्पोजिट फिगर है, स्टैंडर्ड नहीं है। तो क्या कर सकते हैं इसमें, कॉम्पोजिट फिगर में अलग अलग जो स्टैंडर्ड शेप्स है प्रिमिटिव फिगर्स, उसको लोकेट करना है। सो व्हाट वी कैन डू इज, ये जो स्क्वायर है 1 मीटर बाय 1 मीटर वाला, राइट, दिस स्क्वायर जिसका 1 मीटर साइज है, राइट। इस डायग्राम से अगर हम ये जो सेमी सर्कल सॉरी क्वार्टर सर्कल जो बन रहा है उसको हम अगर सबट्रैक्ट कर देंगे इन द सेम वे, ये जो ट्राइंगल है राइट एंगल ट्राइंगल, इसको सबट्रैक्ट कर देंगे तो मुझे गिवन फिगर मिल जाएगा, राइट। सो यहाँ पे कितने डायग्राम से प्रिमिटिव फिगर्स? 3। सो वन इज योर स्क्वायर ऑफ साइज 1 मीटर बाय 1 मीटर। देन उसमें से हमें माइनस करना है, सबट्रैक्ट करना है क्वार्टर सर्कल जिसका रेडियस है 0.75, राइट। एंड ये जो राइट एंगल ट्राइंगल है वो सबट्रैक्ट करना है। इसका बेस है, इफ दिस टोटल इज 1 और ये 0.25 है तो ये बचेगा बेस 0.75। अगेन दिस इज ऑल्सो 0.75 मीटर, 0.75 मीटर, राइट। दिस इज सेकेंड एंड थर्ड फिगर। सो स्क्वायर से माइनस करना है हमें क्वार्टर सर्कल एंड राइट एंगल ट्राइंगल, and we have origin here, right? So it is in the first quadrant. All the values of x, y at that simply means the individual centroid coordinates will be positive. So let's find first for square. So first figure, square of side equal to 1 meter, right? This is the x axis, y axis. This is origin, right? यहाँ पे सेंट्रॉइड रहेगा, सेंटर में इंडिविजुअल जो स्क्वायर है उसका, तो G1। ये जो डिस्टेंस है, राइट, x1, एंड ये जो डिस्टेंस है वो रहेगा y1, करेक्ट। सो व्हाट इज द एरिया ऑफ दिस इज 1 by 1, right? So 1 meter square is the area. Correct? Now what is x1 and y1? Both are same. Half distance of this 1 meter. x1 y1 both are equal to 0.5 meter. Okay. Next figure is quarter circle. Having radius equal to, this is radius, right? 0.75. 0.75 meter. x and y axis. Okay, this is origin O, radius है 0.75, correct. Centroid is somewhere here. Let's say G2 for second diagram. This is first standard area, second standard area, and ये होगा y2 and x2. So x2 and y2 are nothing but the coordinates of the point centroid G2, right? Yes, first find area. So area 2, that means area of second figure, quarter circle. Area of circle is pi r square and quarter circle is 1/4 of the circle. That means area will be pi r square divided by 4, where radius is 0.75. So 0.441786. So you can approximately consider the 3 or 4 decimal. 0.4418, for example, meter square. Okay, exactly it is 0.441786, right? Then next is x2 and y2. Again, here this for quarter circle, from this origin x2 and y2 both are identical, right? So y2 x2 4 r by 3 pi. So it is equal to 4 into 0.75 divided by 3 pi. So 0.3183. So x2 as well as y2 0.3183 meter. And then third figure is the right angle triangle. Right, but x-axis is something like this and y-axis, okay. This is 0.25 and this is 0.75 meter. Okay, this is 0.75 and 0.75, and obviously this is 0.25. Somewhere here you will have the centroid for this right angle triangle. Now this is x3 and here we will have y3, correct, right? So find first area. So this is third figure, A3 triangle, that is why half base height, base and height both are 0.75. Zero 0.28125 meter square. Then x3 is, this is 0.25, 0.25, and for this triangle from this side your distance is 1/3 of base, where base is now 0.75. So 0.25 plus, sorry, 2/3. Let's make a correction. It is 2/3, right? We are calculating from this side. So 2/3 of 0.75. Okay. So we need to add this distance 0.25. So with respect to O, the coordinate of centroid, x coordinate of the centroid is 0.25 plus 2/3 of 0.75, which comes out, I get 0.75. meter. Then y3, again same, this is 0.25 plus this distance, which is again 2/3 of 0.75, standard formulas. So 2/3 of 0.75. So similarly y3 is also 0.75. Okay. Now substitute all the values in the formula. X coordinate of the centroid, right? Summation of A, x upon summation of A by concept of moment of area, right? So it is combination of three figures where we are subtracting this quarter circle and right angle triangle from the entire square. So a1 x1 minus a2 x2 minus a3 x3 whole divided by a1 minus a2 minus a3. Yes, area 1 is 1 and x1 is 0.5. Then area 2 is 0.4418, 0.4418 into CG distance x2 0.3183 minus A3 is 0.28125, 0.28125 into CG distance is 0.75 whole divided by area is 1, area 1, then area 2 is A2 0.4418 and A3 is 0.28125. Calculate the value of x bar, right? So it is 0.5359. I'm going to write here 6 meter. So approximately it is 0.536. And in the same way, y coordinate of centroid, phi bar summation of ay upon summation of a. So a1 y1 minus a2 y2 minus a3 y3 whole divided by a1 minus a2 minus a3. So 1 into 0.5, then 0.4418 is the area, into y2 is again same 0.3183 and y3 is again 0.75. So 0.3183, 0.28125 into 0.75, then 1 minus 0.4418 minus 0.28125, which is again same 0.536. Okay. So as the given figure is symmetric, what you can say? The x and y coordinate is identical. So you can draw a axis of symmetry, something like this. Okay. So about that axis of symmetry, it is symmetric. So your CG will lie somewhere here, right? Both same. So here we have centroid G having x and y coordinate as 0.536, right? तो हमने सॉल्व किया सेंट्रॉइड का एक न्यूमेरिकल. ये न्यूमेरिकल काइंड ऑफ आइडेंटिकल है. So we have same answer. Kind of identical figure है, right? In which we have to consider this entire rectangle and we have to subtract this resembles as a quarter circle of radius 20 mm, and there is one additional rectangle here. So kind of similar numerical. So we have one additional standard figure here. So इसका centroid find करना है again same, right? So what are those 4 diagrams? First is this rectangle, right? Then in the same way you need to subtract these 3 right angle triangle and then this quarter circle. Yes. तो ये न्यूमेरिकल आपको सॉल्व करना है और बताना है विद द हेल्प ऑफ प्रीवियस न्यूमेरिकल ये आपसे सॉल्व हुआ है नहीं, राइट? ओके. So this is next numerical which is from the equilibrium chapter. काफी short and simple sweet numerical है. Circular roller of 1000 Newton weight and 20 centimeter radius hangs by a tie rod AB. So एक AB tie rod है, which is basically tie rod is nothing but subjected to tension. Rod which is subjected to tension, जिसका AB distance जो है वो 40 centimeter है. Rest against a smooth vertical wall. This wall is assumed to be smooth. At C there is a point of contact and determine the tension in the rod and reaction at point C. Okay. So this is from equilibrium chapter. First हमें क्या find करना है? What are the various forces acting on the this roller, right? So we have to draw free body diagram showing all the active and reactive forces. So just understand this, and the solution is quite short. This weight, this is obviously a circle. So center will have this vertical downward force through center of the circle. The weight of the roller is supposed to act, right? And then this rod, tie rod, will be subjected to tension so that it will balance the vertical weight which is acting in opposite direction, downward direction. And here at the point of contact, we have already covered the surface forces and the body forces, right? So when two bodies are in contact, they will exert forces on each other. So here at the point of contact, what will happen? This surface will exert a reaction because it is smooth, so there is no friction basically, and the surface will exert a reaction perpendicular to the plane. So here you will have the reaction, let's say RC, okay, at the point of contact. And let's assume that this is tension. It is tension, but we have to assume first whatever the direction. If answer is positive, assumption is correct. Answer is negative, assumption is wrong. Now I am going to use here one principle which is known as principle of transmissibility. Along the line of action of the force, you can take any point of application. This is just for simplification purpose or for our calculation. So what we can draw here is free body diagram, so showing all these forces. Yes, so right, this is basically a roller. Here is the center through which the weight is supposed to act. Okay, now here we have reaction, right, and tension in rod AB. Okay, now I am going to consider this line of action, and I can just shift this force, and I'll make the point of application through center only, that is B. So what I'm going to draw is the same diagram. But with different point of application for this RC. Okay, correct. Now using Lami's theorem, you can easily find the tension in the rod and the reaction at C. First we have to find the angle between these two forces, these forces. This is basically a concurrent system involving three forces, right, pull type of forces. So first we have to find this angle. This is straightforward 90 degree, but we have to find the other angles. Okay, how to find those angles? So just there is some data given. This weight is 1000 Newton and radius is this radius. This is radius, right? It is 20 centimeter. And the length of AB is given, which is 40 centimeter. So what I am going to draw here is the triangle. Right? तो एक ट्रायंगल है, राइट, दिस ट्रायंगल. ओके, triangle A, C and B, right angle triangle. So I can find this angle, correct? This is 20 centimeter and this length of AB is 40 centimeter. Yes, let's say that angle is theta, correct? So using trigonometry you can easily find this. Yes, adjacent angle, adjacent side and hypotenuse, that means you need to consider cos. So cos theta is adjacent CB, hypotenuse AB, which is equal to what? 20 and 40. Yes, so here theta is equal to cos inverse of 20 by 40. Which comes out as 60. So this theta is 60 degree. Okay, so this angle is 60 degree, correct? This angle is 60 degree. Okay, now I need to find these angles between the forces, right? So consider this diagram. Okay, yes, so there is one force W which is equal to 1000 Newton, 1000 Newton, and this is RC, correct? And here we have tension in rod AB. Okay, this is 90 degree. If this angle is this tension force is making an angle 60 degree with the x-axis, this entire angle will be 90 plus 60, 150. And if this is 150, this is 90, the remaining angle should be 120. As we all know, the addition of these three angles is equal to 360 degree, right? And now you can conveniently use the Lami's theorem to find the reaction at C and tension in rod AB. Yes, what is the Lami's theorem? The force divided by sine of angle opposite to the force 120 degree, that is equal to, what I can write here is RC divided by sine of 150, and that is equal to tension in the rod AB divided by sine 90, right? Now solve for first RC and then for tension in rod AB. Now reaction at C, yes, consider first two. right? W is known. W is 1000. And now solve for RC. It is 577.35. It is positive, means assumed direction is correct. And now solve for tension in rod AB. Consider first and last ratio. So yes, W upon sine 120 is equal to tension in the rod AB upon sine 90, where W is 1000, sine 90 is, you can write down it as 1, right? And tension AB. So tension AB is equal to what? Sine 90 is 1. So what I can write is 1000 divided by sine 120. 1154.70. Okay, let's check the answers. Yes, both are correct, right? So first of all, you need to find what are the forces involved, then draw free body diagram and show the forces, concurrent forces for better understanding. So that means you need to simplify this into this, right? So concurrent force system involving three forces, so conveniently you can use Lami's theorem here, right? And for the angles, you have to consider trigonometry here, right? So it is one of the similar numerical from the previous case. Find the tension in each cable. So from diagram you can say there is one cable AC and there is one cable BC, and at C the weight is attached, the mass of 100 kg is attached at point C, and the angle made by the cables is given. One of the angle is given and one the slope is given, right? So before drawing FBD, we'll first calculate the angle. So here, let's say this is theta, means this angle, right? So consider that right angle triangle. So 4 vertical to 3 horizontal. This is theta. So theta is equal to tan inverse of 4 by 3. It is 53.13. Yes, correct. 53.13. Right. So this is the angle. Now we have to convert this mass, 100 kg mass, into weight, basically force. So force acting due to mass of the body. So we have to multiply this with 9.81, right? So what is weight? mg, and weight is due to gravity. So by Newton's second law, what we can say, F is equal to mass into acceleration, and weight is nothing but contributed because of the gravity, and that simply means a acceleration is due to gravity, and the value is standard 9.81. Unless until mention the value of G, you have to consider 9.81, right? So first we'll draw the same FBD, right? So this obviously weight is going to act in the downward direction, and in the same way, what will happen, whatever the weight, as these are collinear forces, the tension developed in the cable will be same, right? And obviously we can show that this is equal to what? W, right? And here again, these are the tension forces developed in the cables AC, BC, and due to this weight, this weight is nothing but the tension in cable, right, which is attached to the body. So let's draw the body diagram. This is point C. There is weight acting in vertical direction, and there is this tension in BC cable, which is acting at 30 degree with horizontal, and this is tension in AC acting at 53.13 degree with the horizontal, right? This is your forces, right? Again we can use the Lami's theorem, right? Yes. Yes. So we'll find whatever the angles between the forces. Okay. This is weight W acting vertically downward, and that is equal to what? Mg. So 100 into 9.81, 981 Newton. Okay. The next, the tension force TBC. If this angle is 30, this should be 60, right? Okay. And we have one tension force AC, right? If this is angle 53.13, this whole angle is going to be 90 plus 53.13, 143.13, and the remaining angle you can easily calculate. 360 minus 60 minus 143.13, that angle is 156.87 degree, right? Use now Lami's theorem. Yes. What you can write is W upon sine of 156.87 is equal to tension AC divided by sine 60 and tension BC divided by sine of 143.13. So consider first two to get tension in cable AC. Yes, W upon sine 156.87, that is equal to TAC upon sine 60. Okay, what is the value of W? 981. Now solve for tension AC. Two one six two 0.756 you can write. And now tension in cable BC. Yes, consider first and third or any two. So W upon sine 156.87, that is equal to tension BC upon sine 143.13. W is 981. Yes, again similar way solve for tension in cable BC. 1498.4. Yes, let's check the answer. 2162.76 and 1498.4. Minor changes, that is fine. So both are correct. Okay. 10th numerical. Again, it is kind of similar numerical earlier to this. This is based on the same concept. Just here, instead of a vertical surface, here we have inclined plane. So a roller of weight W 1000 Newton. So this is weight. Rest on a smooth inclined plane. It is kept from rolling down if it is not attached with anything, obviously due to its own weight, component of weight along the plane, it will roll down, but it is kept from rolling by attaching it to a string, by a string. So string AC, as shown in figure, find the tension in the string and the reaction at point of contact D. So in the same sense, obviously we have to find these reaction and tension in the string. So what will happen, at the point of contact you will have this reaction RD, correct, and in the same way there is tension in string AC, but here the little bit trigonometry is involved. So first we have to find the angles, right? Correct. So first draw free body diagram. Okay. The center of circle, and we have this weight acting in this direction. What we know from the trigonometry. At the point of contact, this plane is will be tangent, and the radius, obviously we have some theorems in our school time. So this is perpendicular, right? The radius will be perpendicular to the plane of inclined plane at the point of contact. So somewhere here you will have this reaction at point of contact D, and obviously you will have this tension in string AC. So for the simplification, what we are going to do here is I'm going to use a principle of transmissibility, right? So instead of this showing this weight here, I'm going to consider here, right? And instead of this reaction here, I'm going to show that same reaction along the line of action, right? Okay. Now the next part is to calculate the angles, right? This is, let's say, horizontal. Okay. So I have to find whatever the angle made by this and this with horizontal. So let's extend this just to meet this horizontal line. We know this is 90 degree, this is 45, so this angle should be 45. As we all know, the addition, the summation of interior angles of a triangle is 180. If this is 90, this is 45, this should be 45. So reaction is making an angle 45 degree with the horizontal. Then this angle is 45, right? If I draw a horizontal line, this angle is 45, right? And if this is 15, this angle should be 45 minus 15, 30. So this is going to be the angle, correct? So the angle made by tension, what we can show is this is 30, right? Correct? These two angles are equal. So correct? Yeah, let's just draw. Yes, this is FBD, and just draw weight vertically downward, and this RD inclined at an angle 45, and this tension AC is inclined at an angle 30, and the point is center C. Now let's find the angles. Weight is 1000 Newton, right? 1000. Yes, weight is 1000. This is reaction D, right? Reaction at D and tension AC. If this is 30, this angle should be 90 plus 30, 120 degree. And this is 45, this should be 90 plus 45, 135, and the remaining angle will be 105. Correct? Now apply the Lam's theorem here. What I can write is W upon sine of 105 is equal to tension in string AC divided by sine of 135 and RD upon sine of 120 degree. So let's just first consider first two ratios. So tension in string AC, W, which is equal to 1000 divided by sine 105, tension in the string AC divided by sine 135, and from this you can say potential in the string AC is 732.05. Correct? Yes, next reaction at D. So W upon sine 105, that means 1000 upon sine 105, and that is equal to RD divided by sine 120. $896.575. Okay. $732 and $896 both are correct, right? हमने find किया at the point of contact reaction and then tension जो attach होगा, tension जो string में आएगा, right? Now let's move on to the second last topic. We have two numericals, right? Yes. This is quite interesting. Numerical. Block P 5 kg and block Q of M. That means it is unknown. The value is not given for Q block. So block 5, block P is of mass 5 kg and block Q M. It suspended through the cord is in the equilibrium position. So this system is in equilibrium position, and determine the mass of block Q. So we have to find this value of M. So again, what will happen? We can convert this into weight, 5 into 9.81 and M into G. So whatever the weight which is acting downward will be balanced by the force in the cord, this, and obviously the cord will balance itself by developing this. So there will be tension, right? So it is equal to, obviously these are collinear forces, means it should be equal to what? 5 into 9.81, and then there will be some tension in the cord. Let's say this is TAB, this is TBC. Obviously it will be balanced something like this. This is mg and these forces tension CD, right? So what you can draw is, you can draw free body diagram. Yes. Consider first B, and then we can find the tension AB and tension BC, and the same value we can use here in order to find value of M, correct? So due to equilibrium condition given, we can use this. So at B, system is in equilibrium, so whatever the weight attached, draw FBD is 5 into 9.81. Here we have, right, forces. Yes, angle, this is 30 degree, and this is theta, for example, and theta is equal to what? Tan inverse of opposite is 4, adjacent is 3, that means 53.13. Okay. So this angle is 53.13. So tension BC and tension AB. Yes. Now this is acting downward, 5 into 9.81, 49.05. Correct. Tension is unknown, tension BC. This entire angle, this angle will be 120, right? This is 90 and plus 30. Similarly, you can find the angle here. It is 53.13. This is 90 degree. So this whole angle should be 143.13 degree. And the remaining angle, using the summation, is equal to 360. So minus, so it is 96.87 degree. Okay. So apply Lami's theorem, or using Lami's theorem. What you can write is 49.05 divided by sine of opposite is 96.87, and then tension AB upon sine 143.13, and then TBC is TAB divided by sine 120, and TBC divided by sine 143.13. Okay. Is there any need to find the tension in the chord AB? No, but we'll find, determine the mass block, this Q. Anyway, we have to find just BC, but let's find tension in rod AB as well. So first, tension AB. Yes, 49.05 divided by sine 96.87, tension AB. Yes, $42.786 Newton. Is it 42.79? Yes. And then tension in BC or BC is 49.05 divided by sine 96.87, and then TBC is TBC divided by sine 143.13 degree. 29.64. Okay, so it is correct, but they are asking mass block Q, mass of block Q, which is not mentioned in your question bank. The answer, we have to find obviously mass, as it is, as they are asking mass of block Q. So how to find? Now consider C point. Obviously this should be in equilibrium, right? The forces should balance each other. So at C, the tension in CD, it is TCD and it is at an angle 70 degree. What will be this angle? This is again 30, right? These two angles 30. So vertical force at C, there is weight mg at which angle it is given? 70 degree. And look, for equilibrium, this whatever the force will be balanced by an opposite force. So TBC for point C should be taken in this direction, and it is an angle 30 degree with the horizontal. Now we know TBC, right, which is equal to 29.64. Okay, using Lami's theorem. So before, find all the angles. Tension CD, mg, and this TBC, which is equal to 29.64. Now this angle should be 70 plus this 90, 160 degree. If this is 30, this should be 60 degree. And what is the remaining angle? 360 minus 160 minus 60, 140. Okay. Now again use Lami's theorem. What you can write is mg divided by the sine 140 is equal to 29.64 divided by sine 160 and tension CD upon sine 60. So consider yes, first two mg sine 140 29.64 divided by sine 160, right? So m is unknown, g is 9.81, Sin 140 29.64 divided by sin 160. So what I can write is m will be equal to what? 29.64 divided by sin 160 into sin 140 and divided by 9.81. It is 5.678 kg. And there is no need to find tension in CD, but we'll find anyway. How to find? You can consider second and third. So 29.64 chord CD is 29.64 divided by sin 160 is equal to CD divided by sin 60, and you can easily find this value. $75.05. Okay, so there is no answer mentioned for the blocks Q in your question bank. Okay, so this is the answer of your question. Mass of block Q. Okay, the last question for this question bank is on the same equilibrium topic. Two spheres are given, A and B, and which are resting on the smooth surface. This all from all sides it is smooth. Draw free body diagrams of A and B showing all forces acting on them, and both in magnitude and direction. And radius of sphere A, B is 250 and 200 mm respectively. So first, these are two sphere A and B. Okay, at this point A, let's say this is one of the point, second, third, these are in contact with the smooth surface, and at this particular point they are in contact with each other, right? So obviously there will be some reaction there. So first here, okay, so let's say this is R, okay, 1, 2, or any of the letter you can consider. So let's give this as C, D, E, and this point as F. So RC, RD, RE, and here you will have RF. Okay, so draw a diagram showing free body diagram. Okay, okay, something like this, right? So through this, the weight is supposed to act 200 Newton and 500 Newton, and there is one reaction here RE. There is one reaction here, RD. There is one reaction here, RC. Okay, these are the forces. But if you separate out these two spheres, A and B, you will get to know this reaction, right, at the point of contact. Now, let's move this away or isolate this. So what will happen? Isolate this. So you will be having one reaction here, right? Let's say that point is F, right? Yes, F. So this is point F. So we'll have reaction F, equal and opposite, right? Okay. Now first consider sphere B and find these reaction RE and RF, and then you can solve for this sphere A. Okay. So first of all, we need to find the angles. Angles, yes. Okay. This is 60. So obviously this angle should be 30 degree. Correct? So RC is making an angle 30 degree. Correct? Now, to find the angle made by reaction F here. So draw a horizontal line. Okay. At the point of contact, obviously, both the radius of the sphere will be making an angle 90 degree with the tangent, and you can draw a straight line, obviously, through the AB. Okay. This total is 600. So this distance is given. The diagram is incomplete here. The distances are mentioned in the question. Yes, 250 and 200, right? So what we can find is this distance is nothing but a radius, right, which is for sphere B is 200 mm and for sphere A is 250. So what will be the base of this triangle? Total is 600. 600 minus 200, so it is 400. Correct? And this is basically what a radius of sphere A plus radius of sphere B. Correct? So draw a triangle. Okay. So here it is 400 and this is 250 plus 200, 450. Okay. Now I am going to find this angle which is making the reaction making an angle with horizontal at F. So find this angle theta. So we can find this angle angle 4 theta which is tan inverse of not tan, right, cos inverse of 400 divided by 450. So the angle is 27.266. Okay. So for sphere B, right, this sphere B yes. Now consider for sphere B, is draw a similar diagram with concurrent force system. Using principle of transmissivity, what I can do is I can show this reaction force along the line of action, and in the same way, right, so 200 Newton in the downward direction through that center of sphere B. Then reaction E and reaction F. This is making an angle 27.266. This is exactly 90 degree, right? Yes. So find the angle between them. 200 Newton. This is reaction E and reaction F. Yes. This angle should be 90. This angle will be 90 plus 27, 117.266, and the remaining angle will be 152.734. Yes. So using Lamy's theorem, find RE and RF. 200 divided by sine of 152.734 is equal to RE divided by sine 117.266, and that is equal to RF divided by sine 90. So consider first two. For value of RE is equal to here 200 sine 152.734 and into sine of 117.266. .058. Okay. Similar way, find RF. consider first and third. So you will get 200 divided by sine 152.734 into sine 90, that is equal to 436.564. Okay, now consider this sphere A. Okay, now this reaction is known, RF, which is 436.564. Okay, now let's just draw the concurrent force system. So this is going to be vertical, right? So the resultant force will be 500 downward and RD upward. So you can just subtract them, they are collinear forces, right? Then RC is making an angle 30 degree with the horizontal. So what I can draw is RC making an angle 30 degree and RF is making an angle 27.266 with the horizontal. So here you can draw RF at an angle 27.266. Okay, so I have reduced the given force system which involved 4 forces. So I have simplified them to use Lame's theorem, which is only applicable when the 3 forces are concurrent. Okay, now let's just find the angles between them. Yes, 500 minus RD, RC which is unknown, and this is RF. RF is 436.564. So now this angle will be 30 plus 90, 120 degree. If this angle is 27.266, this angle should be 90 minus 27.266, which is 62.734. Okay, and the remaining angle will be 360 minus 62.734 minus 120, so it is 177.266 degree. And using Lame's theorem, you can write 500 minus RD divided by sine 177.266 is equal to 436.564, this force divided by sine 120, and that is equal to what? RC divided by sine 62.734. 734. Okay, first for RD consider these two. So 500 minus RD divided by sine 177.266, and that is equal to 436.564 divided by sine 120, and you can solve this for value of RD. You can simplify as well, right? 436.564 divided by sine 120, and this sine 177.266, which is 24.045. It is 500 minus RD, and you can find RD as 500 minus 24.045. .955 Newton. So this is correct, this is correct, this is correct, and last should be 480, 448, somewhere around that. Consider these two. So solve for RC. So from this you can write down RC is equal to 436.564 divided by sin 120, ये शिफ्ट होगा लेफ्ट साइड में, राइट, sin 62.734 and 436.564 divided by sin 120 into sin 62.734. So it is 448.09. Okay, so all our reaction mentioned in the question banks are correct, what we have solved. The answer from the question bank is correct. So also we can also solve this numerical by another method, which involves applying conditions of equilibrium. So what you can show is the system is in equilibrium, right? The system is in equilibrium. So this reaction C, D and whatever RE and 500 and 200 Newton, these are the forces will be in equilibrium. So you can also find these by using conditions of equilibrium. Take moment at any point, let's say at point C, and then find the reaction at B, E, C, but which will involve too much trigonometry. So obviously we are going to avoid such type of scenario. We can easily find the reaction at contact surface and in between these two spheres at the contact by using Lami's theorem. Just you have to draw FBD first, and then you can easily solve for the reaction, right? So students, at Ganesh Academy we are starting new batch for engineering mechanics after your unit test. As you all know, it is quite intriguing subject, so emphasizing the concept of the engineering mechanics is very much important, and obviously you have to idealize some conditions, whatever the industrial application or the actual scenario, actual engineering problem, and how we are going to simplify them by idealizing some something idealizing. So what we actually use will have some application obviously. So because of that, it is very difficult to relate with the analytics what we are using for the mechanics. So obviously we are mathematically modeling here, but how it came, how we have developed some condition mathematical equation for the mathematical modeling of the engineering problem, that we are going to study in this particular course. So I hope you have enjoyed this video, and all the best for your unit test. Thank you.